So Industry 4.0 really did start in Germany, the term Industry 4.0. And it was started with a gentleman called Professor Henning Kagermann from a research establishment called Acatech. And he took this vision to the German government in 2012, and they invested 200 million euros into further research into Industry 4.0. So the term did actually start in Germany, but it actually encompasses all the way through the life cycle of manufacturing, from idea to order, all the way through to recycling and services. Playing a bit of a catch-up game in the UK. So at the moment, the Germans are leading the game, followed by the Japanese and Americans and Chinese. And you see there's no Union Jack on there yet, but we're getting close and we are working very hard at it. And I think, you know, we're starting to showcase some of the great stuff we do in the UK, like automotive, pharmaceuticals, gaming, education. You know, we've got some great things to say about the UK. And as I said before, Industry 4.0 and digitalisation covers all sectors, and mass customisation covers all sectors. So I think, well, I can think quite a few where you've got some large products. How can you customise that? If you go into a supermarket, if you went to a supermarket 10 years ago, you might see 1 or 2 choices of sauces. You go in now and there's thousands of choices of sauces. And there's one company in Germany called My Muesli, and you can actually go online and specify what ingredients you want in your muesli, like take out a few nuts or raisins, and you can design your own muesli and they'll manufacture it to your individual taste and deliver it to your door. If you think that suits your individual taste, you pay more money for it. So that's how you add value, increase productivity. The one that really, really excites me is pharmaceuticals. So if you've got an ailment, no matter what weight, gender, size you are, and you go to the doctor with that ailment, somebody else with the same ailment will be prescribed exactly the same medication as you. Now, what's happening with pharmaceuticals is they're looking at manufacturing pharmaceuticals to customise individual needs. So to actually react with your own DNA. So you might be allergic to certain things, or you might be bigger, so you need more tablets, for example, or more active ingredient. And work's already been done or started in Scotland with an organisation called CMAC, Centre of Manufacturing and Crystallisation, and they're looking at this challenge of mass customisation of manufacturing pharmaceuticals. So it covers all sectors. No matter what you say, it will cover all sectors, this challenge of mass customisation. And it applies all the way across your manufacturing process, from R&D, from design, all the way through to services. And one of the biggest challenges most companies have is, if you go through that life cycle of manufacturing, you'll find there's lots and lots of different data sets and lots of different formats. And the utopia for most of our own factories and our customers is to have one data set. So we have a software that we use called Team Center. And the reason we use that, so we manufacture variable speed drives in Congleton down the road, but we also manufacture bigger drives in Karlsruhe in Germany. We manufacture different drives in China. But as far as the consumer's concerned, they want the same look and feel. So if you don't have that connectivity with your factories all the way around the world, every drive could have a different look and feel. That means you have to train somebody up each time you use a different drive from Siemens. It wouldn't work. You'd be out of business. So our vision is to have one existence of the truth, one template that you vary within each sort of product platform. And it covers the whole life cycle of manufacturing. So if you design something in 3D CAD in the R&D environment, make sure in your planning process and your production process that you're working with the same data all the way through to services. And then the next challenge is, as you're manufacturing, you're generating data. And the problem there is to how do you harness that data? So we've developed an approach to this called MindSphere, which I'll explain in a bit more detail in a second. Now, the other thing is while you're making products, you don't want to stop your machine to innovate. So this is where your digital twin comes in. Again, all the way through the life cycle of manufacturing. If you're trying things out in the virtual world, you're not affecting production. So therefore, you can keep your productivity going while you're also innovating. And that's what the digital twin gives you in terms of a manufacturing process. So I mentioned earlier on something called cyber physical systems. It sounds really complicated, but it's actually not that complicated. And the example I use for this is a bottling line. So on a bottling line, you'll have a filling machine, you'll have a labelling machine, you have a capping machine. And if you isolated each of those machines down to individual production units, Ideally, what you would do is you'd put all the data together into a virtual model of that production unit. So it might be a filling machine, for example. And then you put all of this stuff into that virtual world. So some of this you can do today, some of it you can't, but Siemens are working on all of this going into the virtual world. So in the future, your CNC controllers will be developed in the virtual world. Your software for your PLCs will be developed in the virtual world here. And that'll generate the code for your PLC, for your CNC controllers. So everything here will actually go into the virtual world. Why do you want to do this? Well, if you then go through all the prototype iterations in the virtual world, you can then reduce the number of physical prototypes that you actually produce. It doesn't really matter too much if you make a mistake in the virtual world. You can very easily change it. So therefore, you bring products to the market a lot quicker. So we go through all the engineering in the virtual world to such a point where we're happy with all the data. We've gone through to all the prototype iterations. Then we migrate the data across to the physical world. And then we start manufacturing. And as you go through the life cycle of manufacturing your product, your digital footprint will get bigger and bigger and bigger. The bigger that digital footprint becomes, the more you can do with it. So potentially the machine could self-optimize, it could self-adapt. It could potentially self-heal. You're probably thinking, what's he on about now? Self-healing doesn't make any sense. Well, some of the technologies behind self-healing already exist. Things like condition monitoring. So a good example of that, Heathrow Airport have 4,000 conveyors in their baggage handling hall. Each conveyor will have 1 or 2 motors. Within each motor you may have 1 or 2 bearings. It just takes one of those bearings to fail and there'll be havoc all around the M25. However, if you analyse the vibration, the harmonics of the vibration of that motor, or the mechanics around it, if you look at the temperature as well, and then manage that data, that big data challenge, and convert it into business data, you can identify when that bearing is going to fail before it actually fails by looking at trends and historical data that you've already got. So therefore, you can then make a human decision. Do I want to stop that conveyor now and repair it? Do I want to slow it down so it actually lasts a bit longer, so therefore I can repair it at the normal maintenance period? Or do I don't want to divert production to another conveyor? So that's, at the moment, a human intervention. But in the future, when we have flexible environments, fully connected environments, the machine can make that own decision itself. So that's what I mean by self-healing. It doesn't necessarily fix itself, but it actually adapts to that information. So right, we've started making our product, and we've got all this big data now. If we migrate that data across into our digital model, so we're making product A, and now we want to make product B, going back to that challenge of mass customization. You can then re-engineer in the virtual world while you're still making products. And once you've gone through the prototype iterations with product B, you migrate it across to the machine and you make product B. And that is why cyber-physical systems will be one of the steps towards mass customization.